Hi, Dr. Anthony Revis here. This is a quick and dirty video to solve a thermodynamic problem involving heat of reaction of two solutions that are mixed. The problem reads as follows. A solution is made by mixing 266 mils of ethanol, 266.0 mils of ethanol, initially at 10.4 degrees C with 266.0 mils of water initially at 23.5 degrees C. What is the final temperature of the solution assuming that no heat is lost? And then it gives the density of ethanol at 0.789 gram per mil and the density of water at 1.00 gram per mil. The specific heat is 2.46 joules per gram degree C, and the specific heat of water is 4.184 joules per gram degree C. Now, it's very important that you note that since it said no heat loss, that means that the heat of ethanol equals minus the heat of water. And we know the equations for doing these types of problems involves heat equals mass times specific heat times delta T. So these are the equations that we have to know. Okay? And we're looking for the final temperature. Now, the final temperature for the rise in ethanol will be equal to the final temperature for the fall in water. So we are essentially saying that the heat of ethanol equals, again, minus the heat of water. So we have all the givens. Now, go back to the equation. The equation says Q equals ms delta T. We're going to use delta T to try to find the final temperature. We know the specific heat of ethanol and water. What we don't know is the mass, but we indirectly know that because we know the volumes. If we know the volumes, we can use the density to do a dimensional analysis to get the grams. So we carry out a conversion of mils of ethanol to grams of ethanol, and we do that and we get approximately 210. Now for speed, I'm actually going to round off some of these numbers, but be sure to do the calculation to the right number of sig figs. For example, we have 266.0 mils is the volume, so you really want to get 4 sig figs there. But for speed, I'm actually doing this where some numbers will be actually rounded off. So be aware of that, okay? So we have the grams now of ethanol. To get the grams of water, we do the same type of calculations, convert mils to grams, and that's a straightforward dimensional analysis. 266 mils equals 266 grams of water because the density of water is 1. So now that we have these converted to grams, we can now start to use our Q equals ms delta T equations. Now here's the trick and here's the key. Again, Q ethanol equals minus Q of water. So what you're going to do is set these two equations equal to each other. Set the entire equation equal to each other because the final temperature, the the TF for each of these will be exactly the same. So we set that up where we have M ethanol times S of ethanol times delta T of ethanol equals minus M water minus M water times specific heat of water and delta T of water. We set these two equations up, and this is a matter of math now. So this is a math part. So we're not going to really go into the details on re-explain the math. We'll just show it to you here on this page. You have to solve through the math, so you might want to review your math for solving these types of equations. And essentially, you're going to set it up where you can solve for T final. And I show you how to do that in 1, 2, 3, 4, 5, 6 steps. I take you through here, and you get a T final of 19.4 degrees C. Make sure you check the sig figs on these now to make sure that I've done justice to them, because I may have been a bit sloppy in terms of doing that. So, bottom line is, you'll take these two equations, set them equal, then use basic math rules to solve for TF. And again, if you're having difficulty with the math rules, you might want to review that or talk to a math tutor. But I show you the steps to go through here, and once you see them, you'll probably recall how to do it then. But anytime you see a problem like this, you want to set the two equations equal and then solve for the missing variable. In this case, it's T final. All right? So there you have it. That's how you would do this particular problem.